This is lesson 3-2, linear versus nonlinear. In this lesson, you will learn how to identify if a relation is linear or nonlinear. So linear is when a linear relation is graphed on a coordinate plane and it forms a line. You can see in the word linear, we have line. Nonlinear is when a nonlinear relation is graphed on a coordinate plane and it does not form a line. We're talking about a straight line, not a curvy line or wavy line. All linear equations form a straight line when graphed. A linear equation is typically in the format of y equals mx plus b, which is called slope-intercept form. There's one exception to that, which is the equation in the format of x equals a number, such as x equals 2 or x equals 5. This type of equation forms a vertical line. Vertical is straight up and down. And it is not a function because it fails the vertical line test. However, even though it's not a function, it is still linear because it forms a line. So some examples of linear equations include the parent graph of a linear equation is just y equals x. You may have a coefficient on your x, such as y equals 2x. You might have a constant in your equation. So you have a coefficient on your x and then maybe a constant attached. That's slope, and these are all in slope-intercept form. You might have an equation like y equals a number, such as y equals 2. That is a horizontal line. And then you could have x equals a number. That is a vertical line. Examples of nonlinear equations include y equals x squared. So we have a power greater than 1, because back on the linear equation, the power on this x is an understood 1. So we have a power greater than 1, it's a power of 2. That would not create a linear line. Would not create a line. That actually creates a U-shaped parabola. That could also have a coefficient on it, and it could have a constant attached to it. It still would create a parabola, which is not linear. Okay, we might have an exponent of 3. This time I'll give it a coefficient and a constant. It doesn't matter as long as it has an exponent on that x of a 3, it will not form a straight line. That's a cubic function. Okay, so anything we have an exponent on the x greater than 1, so an exponent on x greater than 1, it will not be a line. It will not be linear. And then one other odd one is when you have an exponent on the y occasionally, like y squared. Even though I realize that x has a 1, the y has a power of 2 on it, and that will form a sideways parabola like this. And that's not going to be a straight line. All right, here's some examples of equations graphed along with their ordered pairs. Okay, you can see that this is in slope-intercept form, and that makes a linear equation. This is what I was speaking about, where you have a power of 2 on the x, makes that U shape. This is called a parabola, so it is not a straight line. Here's another equation that is linear. This could be negative, by the way. If it is, the line will just go downhill instead of uphill. So that is linear. And then in this example, we have the power of 3, and that makes this funky little shape here, and that's a cubic function, and it is not linear. So this section is comparing functions with linear. So this section, these are all functions. Everything in this circle is linear, and then everything overlapped is a linear function. So these are not lines, and this is not a function. All right, let's go through this table here. This will help you as you run through the questions that follow it. So these are examples of linear equations. This one is in slope-intercept form, and this one is not in slope-intercept form. Notice there's still an understood 1 on that x. Okay, so that is a function, and it is linear. These are examples where you have an exponent of 2 on your x. This is different formats of the equation. It makes a parabola, a U shape. If we did the vertical line test on it, it would only cross it once, so it is a function, but it is not linear. These are cubic examples. Notice there's a 3 on the x. Those are 2 different formats you might see the equation in. That does not make a perfectly straight line. It is a function if you apply the vertical line test, but it is not linear. Okay? Y equals a number, gives you a horizontal line. It is a function, it passes the vertical line test, and it is a line. X equals 1 is a vertical line, therefore it does not pass the vertical line test, so it is not a function, but it is a line. So that's kind of the oddity in here. And then this one we talked about earlier, where you have an exponent of 2 on the y, okay, gives you your sideways parabola, and if you apply the vertical line test, it hits it twice, so it is not a function, and it is not linear. Go ahead and finish up the rest of the practice problems. That concludes lesson 3-2.